All right, today we're going to be learning how to simplify rational expressions. Rational is just a fancy term for a fraction. So we're going to take two expressions and it's going to be a ratio of two expressions or two polynomials. Okay, so as I look at 1 through 5, this is the basics of simplifying, right? So in number 1, we have a fraction or a rational that is 22 divided by 14. So we think, what is the biggest number that goes into both of those in order to simplify? Well, that number is 2. So if I were to divide 22 by 2, well, then that leaves me with 11 in the numerator. And then if I were to divide 14 by 2, that would leave me with 7 in the denominator. Okay, and so I can't simplify any more than I already have. So my simplified answer is 11 over 7. Okay, and then in number 2, we have something that is an expression. Okay, the numerator over the denominator. What I want you guys to notice is that we're multiplying everything, so everything is factored here. And so I can simplify an x in the numerator with an x in the denominator. I can do that again with another x, and then I cannot simplify the factor of x plus 1 with any of these because this factor is different than these two. So my simplified answer is now x plus 1 over x squared, essentially. X times x is x squared. Okay, and then number 3, okay, same idea as number 2. This just is not expanded. Okay, so if I were to expand this fraction, I would have x times x in the numerator and x times x times x times x in the denominator. And again, I could cancel out an x for an x as long as it's in the numerator and the same thing is in the denominator, okay? Another way I can do that is I notice that I have x to the second power, x to the fourth power. Well, all the x's up top will cancel out with 2 of the x's on the bottom. And so again, my fraction or my simplified answer is 1 over x squared. So when everything cancels in either the numerator or the denominator, so everything canceled here in the numerator, it just simplifies to 1. All right, and then in number 4, we have the number part that we need to simplify. So 10 and 4. So 2 goes into both those numbers. So 2 goes into 10 5 times. 2 goes into 4 2 times. And then I have my variables that I need to take care of. So x over x cancel or simplify. And so my final fraction is 5 over 2. In number 5, we have 33 over 11. So 11 goes into both of those. 11 will cancel and turn into 1. 33 divided by 11 gives me 3. And then the variable part, I'll do that in red. This has an exponent of 1, right? So we have x to the first power over x to the third power. So this x will cancel with one of those, which will leave us with x squared. So my final simplified rational or fraction is 3x squared divided by 1, which is just 1, or which is just 3x squared, I mean. So I don't have to put divided by 1. If you wanted to, you could. Okay, and so that's just kind of the basics of simplifying. Okay, number 6, it talks about Andrew simplified a few different things. I'm going to kind of skip this for right now. I just don't want to confuse you guys. And so I'm going to kind of explain what's going on and how I just simplified. Okay, so a rational expression. Again, rational, just a fancy term for fraction. But the technical definition, it's a ratio of two polynomials. Okay, so we're going to have a fraction. All right, so let's look at this, and I'm going to give you guys an example. Here is an example, x squared plus 3x minus 4 over x minus 1. Okay, so here is a rational expression. Okay, I have a polynomial in the numerator divided by a polynomial in the denominator. Okay, and we need to figure out what constitutes as a term versus a factor. Okay, so if I look at this example, okay, I'm going to circle each term. So there's 1, 2, 3, 4, 5 total terms in this example. Okay, and so what a term is a single mathematical expression. So I'll just say a single math expression. And they are separated by the plus and minus signs. Okay, so those are terms. We cannot simplify terms. Okay, and so the most confusing part about this is being able to identify a term versus what a factor is. Okay, so I'm going to take the same example, and now what I'm going to do is I'm going to factor. I'm going to write this in its factored form. Okay, so again, I'm going to have a fraction. Okay, but instead now this numerator right here, okay, is going to be factored. Okay, how do I factor? In my class, we take the last term and middle term there. So remember, I'm looking for two numbers that have a product of -4 and a sum of +3. That is -1 and +4. So x squared, so again, this numerator, x squared plus 3x minus 4 factors to be x minus 1 times x plus 4. Okay, and then my denominator here, the x minus 1, well, that just stays x minus 1. Okay, and so notice I did put parentheses around that bottom part. So when I'm determining what is a factor, well, now I have 1, 2, 3 factors. So factors are separated by multiplication and division. Okay, and so factors is what we can simplify. Okay, so we want it to look like this. All right, so rules for simplifying a rational expression. First, we need to factor both the numerator and denominators. And then the second thing is we're going to simplify or cancel our factors. Okay, so again, very important to know the difference between terms and factors. I can simplify factors or cancel factors. I cannot do that with terms. Okay, so let's look at this. So in number 7, we have 1, 2, 3, 4, 5 factors. Let me do that in a different color right here. 5 different factors. Okay, so everything is already factored. Everything is being multiplied or divided, right? X plus 10 times x minus 4 divided by 5 times x minus 4. So this is already factored for us. It's already done the first step. So all we need to do is simplify or cancel things that are the same. So when I cancel, I look for things that are the exact same. X minus 4 and x minus 4 are the exact same factor. So I simplify that, I cancel that out, And from here, I think that's all I can do. So what I'm left with is x plus 10 in the numerator and 5x in the denominator. So this is my final simplified fraction. Okay, same thing with number 8. Number 8, we have 1, 2, 3, 4 factors, because again, we're multiplying the expressions that I just highlighted or dividing them. And so then now I look to see what I can simplify. I notice that x minus 2 and x minus 2 are the exact same thing. So I can simplify those. And now I write what I have left. X plus 8 in the numerator and x minus 15 in the denominator. Okay, again, these are terms now. I cannot cancel this x with that x because they're terms. They need to be factors. All right, so that's my simplified answer. Number 9, again, it looks like step 1 is done, okay, but I need to look a little bit closer. This factor right here can be factored some more, okay? So what that means is my original problem is x minus 2 times x plus 12. That was already factored. Then I had x minus 2 in the denominator, and I can pull out another 2 out of the highlighted term or expression I just had, and this gives me 2 times x plus 12. So this right here turned into these 2 factors. Okay, so I need to make sure that I have factored completely before I start simplifying. And now I can start simplifying. X minus 2 and x minus 2 cancel. X plus 12 and x plus 12 cancel. Everything in the numerator canceled, so that means it is 1. And then I am just left with 2 in the bottom, so this simplifies to 1/2. All right, so you can kind of see now we're getting a little bit more difficult. So in number 10, nothing is factored. Okay, so that means I have to factor everything. So the numerator factors to be 2 times x minus 4. Okay, and then the denominator is the difference of 2 perfect squares. So we've practiced that before. So I have x minus 4 times x plus 4. Everything is completely factored now. Now I can start simplifying. An x minus 4 with an x minus 4. And I'm left with 2 in the numerator and x plus 4 in the denominator. Okay, so factoring is going to be a very, very vital role in how we simplify these. Okay, I'm going to move on to actually just go to 15 through 18. Okay, and so there's going to be a mix of things that need to be factored and things that are already factored. Okay, so again, we need a factor, number 15. So the trinomial right here is going to factor into 2 spots. I have x. I need 2 numbers that multiply to get -6, that sum to get +5. That's a -1 and a +6. And then I need a factor x squared minus 1. Again, the difference of squares. That factors to be x minus 1 times x plus 1. And then this x plus 6 is still x plus 6. Okay, so I factored the numerator into those 2 factors and the denominator, this part, into those 2 factors. Okay, and the x plus 6 just stayed the same. Once I factored everything completely, then now I can simplify. Okay, so I cancel out things that are the same, 1 in the numerator with 1 in the denominator, and I'm left with 1 over x plus 1 as my final simplified rational expression. Okay, number 16. Okay, I am going to factor the numerator. So So that gives me 5x is the GCF of those two, and then x plus 2. So the numerator factored to that. And then the denominator doesn't really need to be factored, but I'm going to go ahead and do this twice since it's squared. Okay, so x plus 2 squared means I have x plus 2 times x plus 2. And now I can simplify that with one of those. Okay, I know they're the same, but you can only do one for one. And my final answer is 5x over x plus 2. All right, so with number 17, we are going to need to factor both the numerator and the denominator. The GCF for the numerator is 2x, so that means I have 2x times x plus 3. And then the bottom factors to be 2 times x squared minus 9. But I need to make sure about this. This is still not factored completely because x squared x squared minus 9 is the difference of squares. So again, there is my numerator, nothing changes. And then now x squared minus 9 becomes x minus 3 times x plus 3. Okay. So now it's factored completely. With that, I can start simplifying. I can simplify and cross out the factor of 2. I can simplify the factor of x plus 3. And so that leaves me with x divided by x minus 3 as my simplified fraction. And then the last one, number 18. Factoring the numerator is x minus 6 times x plus 2. Okay, and the denominator down here is going to factor to, let me see here, 2x squared, just doing the box method. Negative 6, it's negative 12, 1, so the two numbers that go in there are 3, negative 3, and positive 4. And so that gives me 2x, is that GCF, x, 2, and negative 3. Perfect. So I have 2x minus 3 as a factor and x plus 2 as my other factor. Now that everything's completely factored, I can simplify the factor of x plus 2, and I'm left with x minus 6 over 2x minus 3 as my simplified rational. And that is it.